When choosing a cable tester for Cat5e, Cat6, Ethernet, RG59, and RG6 cables without exceeding your budget, several factors come into play. Let's consider some affordable options and essential features. Firstly, the ClientTools VDV500.824 cable tester is available for around $50. Then there is the Fluke Networks Micro Scanner 12 cable and wiremap tester, which costs around $80. Next is the Ideal Sure Test Professional Cable Tester for approximately $90. Also consider the Greenlee C8T5/C86 cable tester at about $100. Finally, the Network Innovations PC81000 Ethernet cable tester can be found for roughly $120. When selecting a cable tester, the supported cable types is a primary consideration. Ensure that the meter can handle Cat5e, Cat6, Ethernet, RG59, and RG6 cables to meet your specific testing needs. Another essential feature is the wiremap function, which verifies wire continuity and identifies miswiring, such as shorts, opens, and cross wires. This feature helps ensure proper cable connections. Distance measurement capability allows you to determine the length of cables, which can be useful for identifying cable runs and troubleshooting issues related to signal loss or attenuation. Tone tracing functionality generates a tone that can be followed using a probe to locate cables within walls and ceilings, simplifying cable identification and tracing in complex wiring environments. Auto-identification automatically detects the cable type connected to the tester and provides accurate test results, reducing the need for manual configuration and minimizing errors. An LCD display provides clear and easy-to-read test results, facilitating quick interpretation and troubleshooting. An ergonomic design ensures that the tester is comfortable to hold and operate for extended periods, particularly when performing numerous cable tests in succession. These testers offer a balance of affordability and features, making them suitable for a wide range of applications, including home networking, IT support, and telecommunications. It is important to note that the specific features and capabilities of each cable tester may vary, so it's advisable to carefully review the product specifications and choose the model that best aligns with your particular requirements and budget. To provide a more in-depth look at cable testing, let's examine several aspects in detail. The selection of the appropriate cable tester hinges on the specific requirements of the task at hand and the budget allocated for the equipment. The testers offer a variety of features and capabilities, each catering to different needs in cable testing and network maintenance. The ClientTools VDV500.824, priced around $50, is a basic cable tester suitable for simple continuity testing and identifying wiring faults in Ethernet cables. It typically supports RJ45 connectors for testing Cat5e and Cat6 cables, and may also include adapters for testing coaxial cables like RG59 and RG6. This tester is designed for users who need a straightforward tool for basic cable verification and troubleshooting. The Fluke Networks Micro Scanner 12, costing around $80, is a more advanced cable tester that offers additional features such as wiremap display, cable length measurement, and fault identification. It can test various cable types, including Ethernet, coaxial, and telephone cables, and provides detailed information about the cable's wiring configuration and performance. This tester is suitable for professional network technicians and installers who require comprehensive cable testing capabilities. The Ideal Sure Test Professional Cable Tester, priced around $90, is a versatile tool that combines cable testing with network troubleshooting features. It can perform wiremap testing, measure cable length, identify faults, and also conduct network connectivity tests such as ping and trace route. This tester is designed for network administrators and IT professionals who need a single tool for both cable testing and basic network diagnostics. The Greenlee C8T5/C86 cable tester, costing around $100, is specifically designed for testing Ethernet cables and verifying their compliance with industry standards. It can perform wiremap testing, measure cable length, and identify faults, and also provides pass/fail indication based on TIA/EIA standards. This tester is suitable for network installers and technicians who need to ensure that Ethernet cables meet the required performance specifications. The Network Innovations PC8000 Ethernet cable tester, priced around $120, is a high-end cable tester that offers advanced features such as cable certification, network performance testing, and fault diagnostics. It can perform comprehensive tests on Ethernet cables, including wiremap, length, attenuation, and crosstalk measurements, and generates detailed reports that can be used for cable certification and troubleshooting. This tester is designed for professional network installers and consultants who need to provide documented proof of cable performance and compliance. When choosing a cable tester, it's important to consider the specific cable types that you need to test, the features that are essential for your tasks, and the budget that you have available. Basic cable testers like the Klein Tools VDV500.824 are suitable for simple continuity testing and fault identification, while more advanced testers like the Fleet Networks Microscanner 2 and Network Innovations PC8000 offer additional features such as wiremap display, cable length measurement, network connectivity testing, and cable certification. The ideal Sherrod Test Professional Cable Tester and Greenlee C85/C86 Cable Tester provide a balance of features and affordability, making them suitable for a wide range of applications. In addition to the specific features of each cable tester, there are also some general considerations that apply to all models. Firstly, the ease of use of the tester is an important factor, especially for users who are not experienced with cable testing. Look for testers with intuitive interfaces, clear displays, and simple operation. Secondly, the durability of the tester is important, especially if you will be using it in harsh environments. Look for testers that are ruggedly built and can withstand drops, impacts, and exposure to moisture and dust. Thirdly, the battery life of the tester is important, especially if you will be using it for extended periods without access to a power source. Look for testers that have long battery life and can be easily recharged. Finally, the warranty and support offered by the manufacturer are important considerations. Look for testers that come with a comprehensive warranty and are supported by a reputable manufacturer with a track record of providing excellent customer service. Now let's discuss the technical aspects. Cable testers are essential tools for network technicians, installers, and IT professionals, enabling them to verify the integrity and performance of network cables. These devices come in various types, ranging from basic continuity testers to advanced certification testers. Understanding the principles of operation, key features, and testing procedures is crucial for effective cable testing. At the most basic level, a cable tester performs continuity testing to ensure that each wire in a cable is properly connected from one end to the other. This test verifies that there are no breaks or opens in the wires, and that each wire is connected to the correct pin at both ends of the cable. Continuity testers typically use a simple circuit to check for electrical connectivity and may indicate the presence of a fault with an audible tone or a visual indicator. Wiremap testing is a more advanced form of cable testing that not only verifies continuity but also checks the wiring configuration of the cable. A wiremap test identifies miswires such as cross pairs, reverse pairs, and split pairs, which can cause network performance problems. Wiremap testers typically use a series of LED or an LCD display to show the wiring configuration of the cable and indicate any faults that are detected. Cable length measurement is another important feature of many cable testers. This test determines the length of the cable, which can be useful for identifying cable runs, estimating signal loss, and troubleshooting distance-related problems. Cable length testers typically use time-domain reflectometry, or TDR, to measure the length of the cable, and can display the results in feet, meters, or other units. Signal loss testing measures the amount of signal that is lost as it travels through the cable. This test is important for verifying that the cable meets the required performance specifications and can identify problems such as excessive attenuation, impedance mismatches, and reflections. Signal loss testers typically use specialized equipment to generate and measure test signals and can display the results in decibels or dB. Noise testing measures the amount of unwanted electrical noise that is present on the cable. This test is important for identifying sources of interference such as electromagnetic interference, or ME, and radio frequency interference, or RFI, which can degrade network performance. Noise testers typically use specialized equipment to measure the amplitude and frequency of the noise, and can display the results in volts, or V, or millivolts, or millivolts. Cable certification testing is the most comprehensive form of cable testing and is used to verify that the cable meets the requirements of industry standards such as TIA/EIA 568. Cable certification testers perform a series of tests, including wiremap, length, signal loss, noise, and impedance measurements, and generate detailed reports that document the performance of the cable. These reports can be used to demonstrate compliance with industry standards and to troubleshoot network problems. In addition to these basic testing functions, some cable testers also offer advanced features such as tone generation, which can be used to locate cables in walls and ceilings, and network connectivity testing, which can be used to verify that the cable is properly connected to the network. Tone generation works by injecting a low-frequency tone into the cable, which can be detected with a tone probe. Network connectivity testing works by sending test packets over the cable and verifying that they are properly received by the network. When performing cable testing, it is important to follow proper procedures to ensure accurate and reliable results. Firstly, always disconnect the cable from any equipment before testing it. Secondly, use the correct adapters for the cable type being tested. Thirdly, calibrate the tester according to the manufacturer's instructions. Fourthly, perform the tests in a clean and dry environment. Finally, document the results of the tests for future reference. In summary, cable testers are essential tools for network technicians, installers, and IT professionals, enabling them to verify the integrity and performance of network cables. These devices come in various types, ranging from basic continuity testers to advanced certification testers, and offer a variety of features and capabilities. Understanding the principles of operation, key features, and testing procedures is crucial for effective cable testing. The choice of cable tester should be based on the specific requirements of the task at hand and the budget allocated for the equipment. Let's delve a little deeper into common cable faults and how these testers help identify them. Cable faults can significantly impact network performance, leading to slow data transfer speeds, intermittent connectivity, or complete network outages. Identifying and resolving these faults quickly is crucial for maintaining a stable and reliable network. Here are some of the most common cable faults and how cable testers can help detect them. Firstly, open circuits. An open circuit occurs when a wire within the cable is broken or disconnected, preventing the signal from traveling through the wire. Cable testers can detect open circuits by performing a continuity test, which verifies that each wire is properly connected from one end to the other. If a wire is open, the tester will indicate a lack of continuity, indicating the presence of an open circuit. Secondly, short circuits. A short circuit occurs when two or more wires within the cable come into contact with each other, creating an unintended electrical path. Cable testers can detect short circuits by performing a wiremap test, which checks the wiring configuration of the cable. If two or more wires are shorted together, the tester will indicate a miswire, indicating the presence of a short circuit. Thirdly, cross pairs. A cross pair occurs when two wires in a twisted pair cable are reversed, causing the signal to travel on the wrong wire. Cable testers can detect cross pairs by performing a wiremap test, which checks the wiring configuration of the cable. If two wires are crossed, the tester will indicate a miswire, indicating the presence of a cross pair. Fourthly, split pairs. A split pair occurs when one wire from each of two different twisted pairs is connected to the same pin, creating an improper wiring configuration. Cable testers can detect split pairs by performing a wiremap test, which checks the wiring configuration of the cable. If a split pair is present, the tester will indicate a miswire, indicating the presence of a split pair. Fifthly, impedance mismatches. An impedance mismatch occurs when the impedance of the cable does not match the impedance of the connected equipment, causing signal reflections and loss. Cable testers can detect impedance mismatches by performing a time domain reflectometry, or TDR, test, which measures the impedance of the cable along its length. If an impedance mismatch is present, the TDR test will indicate a change in impedance, indicating the presence of an impedance mismatch. Sixthly, excessive attenuation. Attenuation is the loss of signal strength as it travels through the cable. Excessive attenuation can be caused by factors such as long cable lengths, poor quality cables, or damaged cables. Cable testers can detect excessive attenuation by performing a signal loss test, which measures the amount of signal that is lost as it travels through the cable. If the attenuation is excessive, the tester will indicate a high level of signal loss, indicating the presence of excessive attenuation. Seventhly, noise interference. Noise interference is the presence of unwanted electrical noise on the cable, which can degrade signal quality and reduce network performance. Noise interference can be caused by factors such as electromagnetic interference, or EMI, radio frequency interference, or RFI, or ground loops. Cable testers can detect noise interference by performing a noise test, which measures the amount of noise present on the cable. If the noise level is high, the tester will indicate a high level of noise, indicating the presence of noise interference. By using cable testers to identify and resolve these common cable faults, network technicians and installers can ensure that network cables are properly installed and functioning correctly, resulting in improved network performance and reliability. In addition to identifying cable faults, cable testers can also be used to verify the performance of network cables and ensure that they meet industry standards. This is particularly important for high-speed networks, where cable performance can have a significant impact on network speeds and reliability. Let's explore some of the key performance parameters that cable testers can measure and how these measurements relate to network performance. Firstly, bandwidth. Bandwidth is the amount of data that can be transmitted over a cable in a given amount of time. Cable testers can measure the bandwidth of a cable by performing a frequency sweep test, which measures the signal strength at different frequencies. The bandwidth of a cable is determined by the highest frequency at which the signal strength remains above a certain threshold. Secondly, insertion loss. Insertion loss, also known as attenuation, is the loss of signal strength as it travels through the cable. Cable testers can measure the insertion loss of a cable by performing a signal loss test, which measures the amount of signal that is lost as it travels through the cable. Excessive insertion loss can reduce network performance and can cause network devices to have difficulty communicating with each other. Thirdly, return loss. Return loss is the amount of signal that is reflected back from the end of the cable. Cable testers can measure the return loss of a cable by performing a time domain reflectometry, or TDR, test, which measures the impedance of the cable along its length. High return loss can indicate impedance mismatches or cable damage, which can reduce network performance. Fourthly, near-end crosstalk or next. Near-end crosstalk is the amount of signal that is coupled from one wire pair to another at the near end of the cable. Cable testers can measure the near-end crosstalk of a cable by performing a crosstalk test, which measures the amount of signal that is coupled between the wire pairs. Excessive near-end crosstalk can reduce network performance and can cause data errors. Fifthly, power sum near-end crosstalk or piece next. Power sum near-end crosstalk is the sum of the near-end crosstalk from all of the wire pairs in the cable. Cable testers can measure the power sum near-end crosstalk of a cable by performing a power sum crosstalk test, which measures the total amount of signal that is coupled between the wire pairs. Excessive power sum near-end crosstalk can significantly reduce network performance, especially in high-speed networks. Sixthly, equal level far end crosstalk, or L-fixed. Equal level far end crosstalk is the difference between the signal strength at the far end of the cable and the amount of crosstalk that is coupled from one wire pair to another at the far end of the cable. Cable testers can measure the equal level far end crosstalk of a cable by performing a far end crosstalk test, which measures the signal strength and crosstalk at the far end of the cable. Low equal level far end crosstalk can reduce network performance and can cause data errors. Seventhly, power sum equal level far end crosstalk, or self-fixed. Power sum equal level far end crosstalk is the sum of the equal level far end crosstalk from all of the wire pairs in the cable. Cable testers can measure the power sum equal level far end crosstalk of a cable by performing a power sum far end crosstalk test, which measures the total signal strength and crosstalk at the far end of the cable. Low power sum equal level far end crosstalk can significantly reduce network performance, especially in high-speed networks. By measuring these key performance parameters, cable testers can provide valuable insights into the performance of network cables and can help identify potential problems that could impact network speeds and reliability. This information can be used to ensure that network cables are properly installed and maintained, resulting in a stable and high-performing network.